Hey everyone, welcome back to the channel. I'm Danyani Indian, your guide to making smarter tech career moves. Today we're diving into the top 5 programming languages for 2026. I'll explain why each language matters, where you'll use it, job market signals, real-world examples, and a clear learning path so you can pick the right one for your goals. Stick around till the end because I'll compare them side by side and give practical project ideas you can start this week. Let's get into it. Before we list the languages, a quick note on why 2026 is special. AI adoption, cloud-native architectures, device agnosticism, and stricter security needs are shaping demand. That means languages that excel in data science and ML, safe systems programming, scalable network services, and cross-platform mobile desktop are the winners. I'll highlight those signals: GitHub activity, package ecosystem growth, job postings, startup stacks, and enterprise adoption. As we go through each language, number 1, Python. Short answer, still a powerhouse. Why? Python is the default language for data science, machine learning, and rapidly prototyped backends. The ecosystem, NumPy, Pandas, PyTorch, TensorFlow, is enormous. For 2026, expect Python to dominate ML tooling, orchestration scripts, MLOps glue, and fast proofs of concept. Pros: incredibly easy to read, massive libraries, huge community, excellent for learning. Cons: not the fastest for compute-heavy production without native extensions. Concurrency model can be limiting for high-throughput services unless you use async or separate processes. Use cases: data science, ML research, automation, web backends, Django, fast API, scripting, education. Job market: many roles from research scientist to data engineer and backend developer. How to start: learn Python basics, then pick a track. If ML, focus on NumPy, Pandas, data visualization. And a deep learning framework is backend, learn fast API, relational/NoSQL databases, Docker, and basic deployment. Project ideas: build an end-to-end ML pipeline that ingests CSVs, trains a model with scikit-learn or PyTorch, and serves predictions via fast API. That covers the skills employers want. Number 2, TypeScript. TypeScript is JavaScript plus types. And in 2026, it's the mainstream language for web and many backend services. With frameworks like React, Next.js, and serverless platforms, TypeScript gives developer ergonomics and safety while keeping a massive ecosystem. TypeScript accelerates front-end development, powers full-stack teams using Node or Dino, and reduces runtime bugs with compile time checks. Pros: excellent developer experience, huge tooling and library support. Types prevent many classes of bugs. Cons: long compile time, type gymnastics on very dynamic code bases. Ecosystem still includes dynamic JS packages requiring type wrappers. Use cases: web apps, UI libraries, serverless functions, API backends, developer tools. How to start: master modern JavaScript ES6+, then adopt TypeScript and learn static typing, generics, and declaration files. Learn a framework: React, Next.js, or SvelteKit, and APIs: REST, GraphQL. Project ideas: build a full-stack app with Next.js and Prisma, including typed API routes, authentication, and a deployable serverless backend. Number 3, Rust. If you care about performance, memory safety, and reliability, Rust is the language to watch. In 2026, Rust continues to grow in systems programming, browser engines, blockchain nodes, and performance-critical backend services. Rust's ownership model eliminates whole classes of memory bugs at compile time. And its modern tooling, Cargo, and package registry, crates.io, make it productive. Pros: memory safety without a garbage collector, predictable performance, great concurrency model. Cons: steeper learning curve, longer compile times in some cases. Different programming ergonomics compared to GC languages. Use cases: system tools, embedded, game engines, blockchain, high-performance services, WebAssembly modules. How to start: learn Rust basics and ownership. Practice with small CLI tools, read the Rust book, and build a networked server. or WebAssembly component. Project ideas. Implement a high-performance file processing CLI that reads large datasets, processes them in parallel with async and channels, and writes optimized binary outputs. A great portfolio piece. Number 4. Go. Go remains the go-to for cloud-native services, microservices, and concurrent network programs. Its simplicity, fast compilation, and built-in concurrency primitives, Go routines, channels make it ideal for back-end services and developer tooling. In 2026, expect Go to continue dominating infrastructure code, container tooling, observability agents, and cloud services. Pros: simple syntax, fast builds, excellent for concurrency and networking. Cons: fewer advanced language features, generics only recently added, less expressive type system compared to Rust or TypeScript. Use cases: microservices, Kubernetes operators, CLI tools, backend APIs, observability, and networking. How to start? Learn Go basics, understand Go routines and channels, build and deploy containerized services, and learn about the Go module system and profiling tools. Project ideas: build a resilient microservice, containerize it with Docker. Deploy to Kubernetes and add Prometheus metrics and structured logging to demonstrate production readiness. Number 5. Kotlin. Kotlin has matured into a versatile language for mobile, back-end, and multi-platform development. Backed by JetBrains and with excellent tooling, Kotlin is the modern choice for Android development and is making inroads into server-side apps and cross-platform UI through Kotlin Multi-Platform and Compose Multi-Platform. For 2026, Kotlin is attractive if you're building mobile-first products or want a single language across mobile and backend. Pros: concise syntax, null safety, great interoperability with Java, strong multi-platform story. Cons: smaller ecosystem than JavaScript or Python in some areas, and some cross-platform tooling is still evolving. Use cases: Android apps, shared business logic across platforms, backend services with Ktor or Spring, multi-platform UI. How to start? Learn Kotlin basics and null safety. Build an Android app with Jetpack Compose, and explore Kotlin multi-platform to share logic between mobile and backend. Project ideas: create a Kotlin multi-platform project that shares core business logic between an Android app and a simple backend service. Great for demonstrating full-stack Kotlin skills. Let's compare them side by side. Quick summary: Python is best for AI ML and rapid prototyping. TypeScript for front-end and full-stack web development. Rust for systems and high-performance safety-critical code. Go for cloud-native services and simple concurrent backends. Kotlin for mobile and multi-platform projects. Consider these axes when choosing: performance, developer productivity, ecosystem maturity, job demand, and learning curve. If you want speed and safety for core systems, Rust. If you want to ship web apps and UIs fast, TypeScript. If you want AI, ML, and data work, Python. If you want reliable cloud services with easy ops, Go. If you want mobile-first multi-platform, Kotlin. So how do you pick one? Start with your goals. Want AI or data roles? Choose Python. Want front-end full-stack? TypeScript. Systems or performance engineering? Rust. Cloud infrastructure? Go. Mobile or shared logic? Kotlin. Learning roadmap: pick fundamentals first. Algorithms and data structures, version control, Git, and foundational language syntax. Then follow a project-based path. Build small projects, then expand into deployment, testing, and CI/CD. Invest time in reading docs, contributing to open source, and building a portfolio with 2 to 3 well-documented projects. Time boxing tip: 3 months to get productive on the basics, 6 to 12 months to a job-ready portfolio, depending on prior experience. All right, final tips and resources. Bookmark the official docs: python.org, typescriptlang.org, rustlang.org, golang.org, kotlinlang.org. Follow community content, GitHub trending repos, Hacker News, specialized newsletters, and YouTube channels. If you like this walkthrough, hit like, subscribe, and tell me in the comments, which language are you choosing in 2026 and why? I read every comment and often make follow-ups based on your questions. Thanks for watching. See you in the next video.